Dear students, today we have learned about introduction and principle of NMR spectroscopy. Contents in this PowerPoint slide: introduction of NMR spectroscopy, principle of NMR spectroscopy, relaxation process, magnetic and non-magnetic nuclei, rules to find out nuclear spin. Firstly, we have seen introduction of NMR spectroscopy. NMR spectroscopy is the study of spin changes at the nuclear level when a radio frequency energy is absorbed in the presence of magnetic field. When proton means hydrogen is studied, then it is called as proton magnetic resonance. When other nuclei like C13, F19, chlorine 35 is studied, then it is called as NMR. Generally, in practice, the study of hydrogen means proton itself is called as NMR spectra. Nuclei with odd mass number only give NMR spectra. For example, hydrogen 1, carbon 13, fluorine 19, chlorine 35. Because they have asymmetrical change distribution, spin quantum number for such nuclei will be 1 by 2, 3 by 2, 5 by 2, etc. For hydrogen 1, it is 1 by 2 and therefore it has orientation is 2I plus 1. I means ground state and 2 means excited state. Other nuclei like carbon 12, oxygen 16, sulfur 32, nitrogen 14, hydrogen 2 do not give NMR spectra because of symmetrical charge distribution and their spin quantum number is a integral value. Now we have seen principle of NMR spectroscopy. Any proton or nucleus with odd mass number spins on its own axis by the application of an external magnetic field, which is denoted by H0. The nucleus spins on its own axis and a magnetic moment is created, resulting in a precessional orbit with a frequency called as precessional frequency. This state is called as ground state or parallel orientation. In this state, the magnetic field caused by the spin of nuclei is aligned with the externally applied magnetic field. When energy in the form of radio frequency is applied and when applied frequency is equal to precessional frequency, absorption of energy occurs and a NMR signal is recorded. Because of the absorption of energy, the nucleus moves from ground state to excited state, which results in spin reversal or antiparallel orientation, in which the magnetic field caused by the spin of nucleus opposes means aligned against the externally applied magnetic field. When the application of radio frequency energy is stopped, the nucleus returns to ground state or parallel orientation. It should be noted that increasing the strength of magnetic field does not cause transition from ground state to excited state, but it merely increases the precessional frequency. Without application of magnetic field, there are no two spin states and there is only one average spin. Hence, radio frequency radiation cannot be absorbed. Therefore, application of magnetic field and radio frequency necessary to cause a NMR spectra. Now, we have seen relaxation process. It is the process of transition from excited state to ground state, where the absorbed energy means radio frequency energy can be lost by two ways, in which first way is radiation emission, in which with emission of radio frequency radiation itself, and second way radiationless transition means without radiation. This way is of sub two types. First, spin lattice or longitudinal relaxation process, where the energy is lost by means of transitional or vibrational or rotational energy. And second way, spin or transverse relaxation process, where the energy lost to the neighboring nuclei. The spinning nucleus means the nucleus of the hydrogen atom means proton behaves as a teeny spinning bar magnet, and it does so because it possesses both electric charge and mechanical spin. Any changed body will generate a magnetic field, and the nucleus of hydrogen is no exception. So now we have seen magnetic and non-magnetic nuclei. All atomic nuclei contain nucleonic particles, namely protons, the positively charged particles, and neutrons, which are neutral. As such, the nucleus is positively charged. Like electrons, nucleonic particles spin on their own axis. The circulation generates a magnetic dipole along the spin axis. The angular momentum of the spinning charge can be described in terms of spin quantum number. Individual protons have spin quantum number plus 1 by 2 and minus 1 by 2. The total of spin quantum number, which is denoted by capital I, is a characteristic of the nucleus and depends on the number of nucleons and on the symmetry of charge distribution. Now we have seen rules to find out nuclear spin. First rule, nuclei which have an odd mass number will have odd number of nucleons, and thus they have half integral spin such as 1 by 2, 3 by 2, 5 by 2. For examples, hydrogen 1, carbon 13, nitrogen 13, fluorine 19. Second rule, nuclei which have odd number of protons and neutrons, thus even mass number, have integral spins such as 1, 2, 3. For example, hydrogen 1, 2, nitrogen 7, 14. Third rule, nuclei which have even number of protons and neutrons, thus even mass number, always have zero spin. For example, carbon 6, 12, oxygen 8, 16. Thus, nuclei such as hydrogen 1, fluorine 19, carbon 13, phosphorus 31 have spin quantum number increases by 0, behave like bar magnet, while those with 0 spin, for example carbon 12, oxygen 160, are non-magnetic. Thank you.